On behalf of PSE for Speed Company, it's a pleasure to welcome you here. I'm Kankanok Udamwong, a chemical engineer who professional in software development. I am delighted to be here to talk about a computer-aided software for refrigerant design, analysis, and verification, ProREFD. My presentation is divided into 4 parts. I will start with the background of our development, and then I will look at all the features and case examples. And finally, providing the conclusion of our efficient software. As everyone knows, refrigeration systems are very common since they have been successfully performed and operated in many applications. For that reason, the selection and testing of any refrigerant involve many steps, such as identifying a suitable refrigerant, also testing its efficiency in the actual refrigeration operation. Equally, due to increased health, safety, and environmental concerns, the refrigerant selected from application must satisfy those constraints. Due to the issue that I have mentioned, a computer-aided tool that can systematically guide the engineer through the steps of refrigerant selection and design would be very useful. With these objectives in mind, the ProREFD software has been developed as a computer-aided hybrid tool that is suitable for refrigerant design, analysis, and verification. Starting with the data that are extracted from the developed tool from ProCAPD and OpCAMD, which are our company's tools and including especially developed property model for refrigerant molecule and their associated measure data. Next, fast and reliable refrigeration process model perform simulation and design that reduce time and cost for refrigerant development by focusing on experiments to verify and analyze the cycle performance. Finally, another one significant goal for ProREFD is to minimize the step of refrigerant selection and verification. The tool combine the data from typical analysis tool and property estimation tool that help with the virtual selection and verification step, as well as analysis of available refrigerant candidates. Now, I want to describe the overview of ProREFD software and its tool. The 6 tools of ProREFD highlighted in Figure 1. First, Modeling Toolbox. This tool is a mathematical modeling software, which consists of in-house algebraic solvers, integrators, ordinary differential equation solvers, and optimizer. Second, Database Manager. This tool is for searching and retrieving of the refrigerant property. Furthermore, the collection of measured binary VLE data as well as azeotropic data. There are almost 1,800 compounds with more than 300 refrigerant compounds in this database. And next is property estimation or PEER. This toolbox is for PEER compound and allow users to predict the property, 60 different PEER compound properties, and other property correlations such as heat vaporization or heat capacity. Fourth, property estimation for mixture. This toolbox provides the predicted properties for refrigerant organic mixture that are needed for the refrigeration system design and analysis. Also VLE data and saturated condition as well as properties for a given phase. Fifth, refrigerant selection. The toolbox that helps to design, select, and optimize refrigerants for a specific application based on user-defined requirements. User can select and compare the feasible alternative based on target property or additional property as well as refrigeration cycle simulation. Lastly, refrigeration cycle simulation. This is a toolbox that allows users to perform simulations of a refrigeration cycle. The refrigerant can be a single molecule or mixture of up to 5 compounds. This toolbox also computes thermodynamic diagram and embeds the cycle operation into this diagram. Another useful feature is sensitivity analysis option, where the sensitivity of compound property or operational variables to the performance and duty of cycle are checked. Let's turn to the application example of ProREFD. The first problem is for the refrigerant cycle simulation function. In case R134A is used as a refrigerant example. Figure 2 shows several screenshots from ProREFD. On the left-hand side, the refrigeration cycle simulation is performed and the COP is determined. On the right-hand side at the top, the thermodynamic diagram is calculated and plotted, and at the bottom, by perturbing the operating conditions, the improvement of COP is checked. The next problem is refrigerant selection. In case of replace the specific refrigerant with each R134A with other single or mixture refrigerants, the result of selected refrigerant alternatives are highlighted in Figure T. User can compare each decided alternative and optimize to achieve the most efficient refrigeration. Lastly, the ProREFD results are compared with the external software through illustrative examples. The simulated refrigeration cycle result with R134A as a refrigerant, which are given in the first problem, are compared and cross-variated with the same refrigeration cycle with two external process simulators. The simulated result given in the table 1 confirm that at least the three software tools give approximately similar results. Despite the several industries are one of the first to realize the significant benefit that refrigeration have offered, the capability of ProREFD have been highlighted. The refrigerant selection toolbox has the potential to find appropriate candidates that may not exist in any database of refrigerants, especially mixed refrigerants. Refrigeration cycle simulation helps to identify how to change the operating conditions to improve the process performance by using our model and thermodynamic diagram feature. And the sensitivity analysis helps to identify the parameters of refrigerant that can influence the process operation the most. Evidently, ProREFD is a promising software tool that can play a leading role in a refrigerant process development by helping to find promising and sustainable solutions rapidly, reliably, and efficiently. ProREFD is a unique as no other tool that have all the functions integrated in one software could be found. Thank you for your attention.